Greetings, everybody. Today we're going to do a little in focus thing on how exactly the flat Earth error occurred in radiative greenhouse effect mechanics and the basis of climate alarmism. In the main presentation, we saw that climate alarmism and even most of the field of climate science itself is based on flat Earth physics. So what we want to discuss here is how exactly the flat Earth error occurred. So, flat Earth in focus. So in the main presentation, debunking the radiative greenhouse effect at the basis of climate alarm, we saw that it is all based on flat Earth physics. You see this in this diagram here. The Earth is flat, and we discussed everything that is wrong with that in the main presentation. So how did this mistake occur in the first place? Well, to get there, we need to discuss this concept of effective temperature. So what is effective temperature? Effective temperature is a fictional temperature for an ideal emitter and absorber, i.e. a black body. So a black body is a fictional concept in physics, which is an ideal emitter and absorber of radiant thermal energy. So given an object's radiant thermal surface flux spectrum, what temperature would this correspond to via the Stefan-Boltzmann law if the integrated flux were from a perfect emitter? Generally, things do not emit perfectly, like a black body, but we can say, well, if they were emitting all this energy, like a black body, what would that temperature correspond to if it was a temperature of a black body? So that's what we do here. We integrate the flux over all frequencies, and that gives the total flux, and that's equal to sigma times the effective temperature to the fourth power. That's a Stefan-Boltzmann law. So then we go on to say for the Earth, what is Earth's effective temperature? This is one of the most common exercises in undergraduate physics. Given the solar input to the Earth, what is the effective temperature of the Earth? So this is a question about thermal equilibrium, where the heat flow from the sun is equal to zero, is equated to zero, given that sunlight is not known to be changing Earth's temperature on a long-term basis, and that the Earth should be in thermal equilibrium with the sunlight, given the billions of years that sunlight has been falling on the Earth. Now, this is still not to say that magnetic changes in the sun can't have an effect on Earth's temperature, because apparently they do through modulation of inner solar system cosmic ray flux, which is modulated by magnetic activity on the sun. And these cosmic rays interact with Earth's atmosphere and create clouds. So that does have an effect on the climate, but that's not from a change in the sun's radiant solar output, radiant flux output. Okay, so here's the equation then. Q, heat from the sun, equals the power from the sun minus the power from the Earth, and that's equated to zero, so that the power from the sun equals the power emitted from the Earth. So you have that equation there, and the result comes out to a flux output of 240 watts per meter squared, which is an effective temperature of 255 Kelvin, or minus 18 degrees Celsius. So that's all fine. But where does the error actually occur? How does it occur? How do they get to a flat Earth from there? So here's basically the effective temperature calculation. First of all, you have this top of atmosphere solar flux coming in, and then it's basically transformed through the Earth, stepped down in flux, and comes out as this flux. So what they do is they simply take this flux output of 240 and make it the input. And they say, well, on average, that's the output. And so if that's an average, let's make the average uniform. And let's make it the input. So then they make it the input. So the output flux is reversed and is given as the input flux. And of course, the problem there is that they're equating numerical flux values, which is not a conserved quantity, rather than total energy, which is a conserved quantity. Here we're conserving total energy. Here they're trying to conserve flux, but flux is not a conserved quantity, and we'll see just up ahead what's wrong with that. So it's a reversal of reality. Switching output for input is the initiating error. It illogically reverses reality and then leads to every other extrapolating logical error in violation of physics and reality. It's the initial seed. Now take a look at this, right? Here's the input, really warm, really high temperature forcing potential relatively, and here's the output. The output is 240 watts per meter squared. Look what they did here. They made that the input. It's reversing reality, and then they say, well, on average, that's going to be the output. So let's just make the average a uniform value and global, and you can approximate that with a flat plane. So let's just use a flat plane. So that's what they did. They just said, well, this is the average output, and an average, let's just make that a uniform global average. And since it's uniform and global and there's no variation, the simplest way to approximate that is with a flat plane. So let's just make a flat plane with an input of the output. So there's just all sorts of errors going on here, or all sorts of mistakes going on here. I mean, none of it made sense. None of that procedure, none of those steps made sense. The only thing that made sense was to calculate the effective temperature of the Earth. That's fine. It doesn't make sense to turn around and call the effective temperature of the Earth the input to the Earth. That doesn't make sense at all. So yeah, so flat Earth, assuming uniform output on average, then just use a flat plane to represent it. But the initiating error was already made by reversing, using the output as the input, albeit that the Earth isn't flat in and of itself. So it's just compounding and compounding errors, compounding physically senseless things. So the logical error continues in that the diagram contains a paradox in the distance the surface needs to be from the sun, the heating potential of sunlight, and etc. Everything we discussed in the main presentation. So summary, calculating the effective temperature is a valid procedure in physics and gives a useful characterization of an object, even if the effective temperature is a fictional temperature. We use effective temperature in astrophysics all the time, and it's a very useful fictional temperature to characterize bodies with. And of course, you apply absorptivities and emissivities and things like that, and it's extremely useful, even if it is fictional. Effective temperature is relatable to flux through this equation. However, heat flow is irreversible. It firstly does not make thermodynamic sense to reverse the direction of energy and heat flow through the system. Remember that quote from that textbook in the main presentation? He goes on to a great lengths in that thermodynamics textbook about heat flow being an irreversible process. Well, what do? They reverse heat flow through the system. The heat flow, they completely reverse it. They take this output and now make it as the input, totally reversing the system. It doesn't care. It doesn't matter if they don't say that that's what they're doing or agree that that's what they're doing. That's what they did. It doesn't matter if they think of it as something else. That's what's happening. Okay, secondly, it doesn't physically make sense to exchange the solar input flux for the flux output of the Earth. Okay, so yeah, you can't conserve fluxes. Fluxes are not a conserved quantity. Thirdly, it gets worse by confusion of the terms energy and heat and equating them. They think that just because a cooler object may emit radiant thermal energy, that therefore that energy has to heat a warmer object or will cause a warmer object to become warmer still. That does not make sense. That's not how it works. Heat flow is irreversible. The only way that that radiant thermal energy can cause another object to warm up is if it transfers as heat. Well, radiation from a cooler object cannot transfer as heat, therefore it cannot have any thermal effect on a hotter object. So they use this term back radiation. They say there's back radiation from the cooler object that will cause a warmer object that's heating the cooler object to become warmer still because of back radiation. It's a totally specious, invented, meaningless concept. It's total sophistry. Just think of the term back conduction or even back diffusion of heat. I mean, does heat come back if you're heating a bar on one end? Is there back conduction from heat as the bar is heated through towards the cool end? Like, is there back conduction of heat? That's a totally senseless concept. Is there back diffusion of heat coming back to the warmer end of the bar, causing the warmer end of the bar to become warmer? No, that's a completely meaningless concept, and it does not exist in thermodynamics. This concept does not exist. You can read through all textbooks in thermodynamics. You'll never find a concept of back conduction or back diffusion of heat. The idea of back radiation is totally specious, totally nonsensical. It's total sophistry, totally invented, and it's meaningless. And then fourth, I mean, man, you've really mucked things up already. And now, why not put it in a flat Earth? Well, I mean, why not, right? I mean, you're reversing the direction of energy and heat flow through the system. You're making solar input minus 18 degrees Celsius, freezing cold, unable to melt ice into water. You're not properly conserving energy. You're confusing what energy and heat actually are. You're inventing a term that's meaningless in thermodynamics, back radiation. It's as meaningless as back conduction or back diffusion of heat. Well, yes, in fact, the best place for this is in flat Earth physics. Yes, let's put this in a flat Earth physics model, in a flat Earth model. I mean, you cannot be any more ridiculous. It's absurd. And this is what your children are being taught in school.